Hello guys, this is Samadan Kale and welcome to all of you on my YouTube channel. So guys, we have started this linear algebra course. In this course guys, we will learn in today's video the matrix methods in linear algebra guys. Okay, so matrix methods in linear algebra. Before starting the video guys, if you do not subscribe to my channel, please subscribe it and press the bell icon so that you will get the latest update of videos like of this. And guys, please like the video and share the video. If you like my video, then I will make more and more videos like of this video guys. Yes, so because for making one video I have to take so many efforts. So guys, please like the video and share it. So guys, let's start the today's video. So firstly guys, we have imported in the last lecture or last video, that is a sympy library, that is import sympy as sy or sp, that whatever short form you want to take you can take, but we have to working on matrix guys. So for matrix I have imported the sympy library this in this way also. So from sympy import matrix. Okay, from sympy import matrix, that means guys, from the library sympy I have imported the matrix. Okay, so now if I define the matrix, then it doesn't mean sy dot matrix. Okay, it will be only matrix. That means I don't want to use here the sympy library each and every time. Okay, again I will import the sympy library. Yes, import sympy as sp. Okay, or sy. So guys, for some methods I need sympy library. That's why I have imported it. Okay. So let us take the today's matrix guys. So I have defined A as a matrix. Okay. Now I don't use the sy symbol. Okay. Sy dot. I will use directly matrix because I have imported matrix. So I will use matrix of this. Now I'm taking the first row as 1, 2, 3. Yes. Then second row as -104. Yes, -1, 0 and 4. And my third row is 3, -1 and 1. Okay, so this is my matrix guys. And if I take the A, so I will get the matrix A. Okay guys, so let us take the today's first method. Again I will import another matrix, so that is matrix B. Okay, so B is equal to, that is a matrix. Yes, matrix. I have taken this matrix as 0, then -1 and 1. Then I'm going to take the second row as 2, -2, then 1. Yes, and I'm going to take the third row as 6, then -3 and 1. Okay, so this is my matrix B, and if I print this matrix B, so I will get the matrix B guys. Okay, now guys, let us see the first method of the matrix, that is the add method. Okay, that is the add method. So what is the add method guys? So add method will add the two matrices. Yes, add method will add the two matrices. How it will be add? So I have to use a dot add. That means if I want to add the matrix, some matrix into A, then I will use a dot add. Okay, so a dot, I'm using this as add. Okay, a dot add, and in this add function I have to give some another matrix. Okay, so I'm giving matrix B. So it will add matrix A and B both, and I get this result. Okay guys, if you want to check whether this answer is correct or not, you can check it. Okay, so this is the add method guys. Now second method, or you can take in instead of add 1, okay, you can take B also. Yes, that means guys, we can use instead of A, we can use B also. That means how it can be worked, let us see. So I'm using B dot, then this add, and In this add, I am using A. Okay, the same result I will get, guys. Yes, so this is the thing that we have to remember here. Okay, now let us take the second method, and the second method is, guys, adjoint method. Yes, adjoint method. So how we can find the adjoint of a matrix by using Python. So what it will be written? It will return the conjugate, transpose, or Hermitian conjugate. That means then row of the matrix will become a column. That is the adjoint. Yes, adjoint of a matrix. It will return a conjugate, transpose of Hermitian conjugation. So let us see, guys, if I use a dot, yes, a dot adjoint, a dot adjoint, then what I will get, let us see. If I am taking this, so this will take me 1 minus 1 and 3, 1 minus 1 and 3, and then let us see, this is the matrix A, where our matrix A, this is matrix A, 1 minus 1 3 is the first column, and that 1 minus 1 3 will become now a first row. Yes, so this is the thing that will be adjoint. If I want to find the adjoint of matrix B, so I can use A dot adjoint, yes, or B dot, sorry, B dot adjoint. So I will get the adjoint of matrix B. So this is the adjoint method. Now let us take, guys, the third method, that is the adjugate method. Yes, that is the adjugate method. So what adjugate method will return? Let us see. It will return the transpose of the matrix of cofactors. What is the adjugate method return? It will return the transpose of matrix of cofactor. That means if we find the cofactor matrix, and then if we find the transpose, and that transpose is nothing but the adjugate of the matrix. So how we can find the adjugate of matrix A? Yes, we can find the adjugate of matrix A by using a dot adjugate function. Yes, a dot adjugate, and let us run it. So I will get the cofactor. Okay, these are the cofactors: 4, 13, 1, minus 5, minus 8, 7, 8 minus 7, 2, and this is the matrix of transpose of cofactor. Yes, now if you want to find the adjugate of the matrix B, you can find it. Now let us take the third method, that is the analytic function. Yes, analytic function. So how we can find the analytic function? So this is the method, guys, analytic underscore function. Analytic underscore function. Okay. So it will compute f of A, where A is the square matrix and f is any analytic function. That means we have to enter f analytic function. Firstly, we have to enter the function. Okay. Now, for that function, I have to use the symbols. So I will use x is equal to this sy dot symbol. Yes, sy dot symbol, and I'm going to write this symbol as x. Okay. Now I will define the function f as x square. My function f is x square. Now I will use the analytic function on the matrix A. So what I have to do, guys? I have to do a dot analytic function. Yes. So this is the analytic function. Now here in this analytic function, you have to give the two arguments. You have to give the two arguments. That means the function f and x. Yes. So I'm giving the function f comma x. These are my two arguments. And if I run it, I will get the analytic function. That means it will compute the f of A, where A is a square matrix. Our matrix A is a square matrix and f is a analytic function. So let us see, guys. We have computed this is the analytic function. Yes, f of A. That means this f of A square. It will find the f of A. That means A square. This is the matrix A square. If we take a square, that means a double star 2. Yes. So what it will be? It will be the same. Let us see. This and this are the same. That means by using analytic function, we can apply that function on matrix A. Okay. So this is the thing. Now the next function is apply function. Next function is apply function. So let us see what is the apply function. Yes, apply function. This is again a method. So what this method is used for, guys? So we have to apply a function to each element of the matrix. If we define a particular function, and then we can apply that function to each element of the matrix. Okay. Suppose I will use matrix A, and I'm use the apply function. I'm using the apply function, and in this apply function I will define some function, that is lambda function. Yes, lambda, and I'm going to use this variable as I. Okay, and now I'm defining this variable I as I square. Yes, I square. I want I square. Okay, and let us run it, guys. So I will get this matrix. I will get this matrix. For our understanding, I'm going to print the matrix A again. Yes, matrix A again. So this is my matrix A, and this is the apply function matrix. Now, guys, how this apply function will be applied on this matrix? Let us see. So we have defined this lambda I. I means, guys, the number of rows. The number of rows. So if the value of I is 0, then 0 square will be the 0. So that means this element square will be as it is. That means this one is as it is. So next one is this element. Here the value of I is what? The value of I is 0, 1. 0, 1. So 1 square is 1. One second. This entry is a 0, 1. Then this is a 1. This is a 0, 2. Yes, 0, 1, 0, 0. Then 0, 1. This entry is 0, 0. This is a 0, 1, 0, 2. Again, this is a 1, 0, 1, 1, 1, 2. Okay. In this way, these are the entries. Now, for I means, guys, this first element. Okay. Its square. What is 1 square? 1. Yes. Now, the second element, when the value of I is a 2. So, its square. 2 square is 4. Then its square. That means we will get the square of each number. Square of each number. And if I'm using another variable j, okay, so I want I square plus j. I square plus j. So one second. So it will give me error lambda missing one required positional argument j. Yes, we have given this argument, positional argument, that is a j, lambda I and j, and we have given the comma also. Yes, so I square, and it is a j. Yes, so it should be there, but what will be happen here? Okay, if we don't use this j and here also, then the function will be as it is. Okay, now if I use instead of this I, if I use x comma y, yes, x and y, these are the two parameters, and instead of this I'm using this x square into y. Yes, so x square into y. So then what will happen? It will again give me error, that is lambda missing one required positional argument y. Yes, so that is the thing that we have to remember. So we have to give the x here. Yes, x and its square. That means it will give me a square of that matrix each element. So this is the apply function. Next one is, guys, as immutable function. Yes, as immutable function. So let us see what is this as immutable function. As immutable, so how it will be written? So we have to apply this function on matrix A. Yes, A as immutable. That means it will check or it will return the immutable version of the matrix. Immutable version of the matrix. So it will give me this is the matrix, that is the original version 1 2 3 minus 1 0 4 and 3 minus 1 1. That means guys we have applied so many methods on matrix. Then if you want immutable version, you can take the immutable version. The same thing that I can write as mutable. Yes, as mutable version. That means the mutable version I will get when I will use as mutable function. So I will get the mutable version of the matrix. It will be again the same. Now let us take the next method, guys. So what is the next method? This is a as real imaginary method. Yes. So let us see what is this as, then underscore, then real, and then imaginary. Yes, image means imaginary method. Okay, yes, so this is the method. And if I use this method on matrix A, then what it will be written? It will return a tuple. It will return a tuple containing the real and imaginary part of the matrix. Yes. So if there are two parts in the matrix, real part and imaginary part, then it will return a tuple of real part and imaginary part. Okay. So for example, if we take a dot real imaginary function and if we run this, so we will get a tuple or it is a series. This is the tuple. So in this tuple, this is the first matrix. This is the first matrix. So in this first matrix, we get the real entries. So let us see there are real entries only in the matrix A. So this is the matrix A. And the imaginary entries are all 0. That's why it is a 0. Yes, if in our matrix there are imaginary entries also, so then it will give me as real entries in the first element and imaginary entries and in the second element. Okay, so this is the as real imaginary function. So next function is atoms function, guys. So what it will be written? It will return atoms that form the current object in dictionary. Yes. So this is the atoms function. Atoms function. So what is the atoms function? Let us see. Let us apply this atoms function on the matrix A. Yes. So atoms. If you want to check what atoms return, it will return the atoms that form the current object. That form the current object. That means we have to form the current object. That means it will take each and every element in the dictionary. Let us see. We will get the output in the dictionary. That means the first element, second element, third element, and so on. Okay, minus 1, 0, 1, 2, 3, and 4. These are the atoms of the matrix. Yes. So guys, let us take the next method. That is a Berkowitz method. Okay, Berkowitz method. So what is the Berkowitz method? Let us see. Firstly, I'm writing here the Berkowitz method. Okay. So what is this Berkowitz method? If I apply this method on matrix A, then what I will get? Let us see if I run this. So I will get this is the element. That means guys, it will return the characteristic polynomial roots. The roots of the characteristic polynomial by using Berkowitz method. Okay, by using the Berkowitz method. What is the Berkowitz a dot Berkowitz function? So it will return the characteristic polynomials root by using the Berkowitz method. Okay, so this is the thing. Now, if I want the characteristic polynomial. If I want characteristic polynomial using this Berkovitz method, so I can use a dot Berkovitz characteristic polynomial. Berkovitz characteristic polynomial. That means this is the function, guys. Berkovitz char polynomial. Char polynomials means characteristic polynomial. Okay. If I run this, so I will get the characteristic polynomial. This is the pure polynomial. It is in a lambda form. Let us see. Lambda cube minus 2 lambda square minus 2 lambda minus 33. Yes, 33 lambda, and its domain is z. That means all these roots are belongs to the set of integer z. So it will return the characteristic polynomial of the matrix with its domain. That means where these roots are belong. Yes, so this is the Berkovitz characteristic polynomial. Next method is, guys, same, Berkovitz determinant. Berkovitz determinant. That means it will compute the determinant of the matrix using the Berkovitz method. Yes, using the Berkovitz method. So what it is? Let us see. This is the Berkovitz determinant, and if I run this, so I will get the determinant of matrix by using the Berkovitz method. Yes. So next one is Berkovitz eigenvalues. Berkovitz eigenvalues. So I am using a dot this Berkovitz eigenvalues. Here are the functions. That's why I'm taking the benefit of this Berkovitz eigenvalue. That means I will get the eigenvalues of the matrix by using Berkovitz method. Same thing. These are the eigenvalues of the matrix A, guys. Okay. Now let us take the next method. That is Berkovitz minor. Berkovitz minor. So what it will be take? It will compute the principal minors using the Berkovitz method. So what are the principal minors, guys? You can learn these principal minors in mathematics. Yes. So Berkovitz minors. So I will get the principal minors of the matrix, that are the 1, 1, 2, and 33. These are the principal minors of the matrix by using the Berkovitz method. So guys, in this video, we have learned some methods of the matrix. So remaining methods of the matrix, I will take in the next video. So for that, you have to wait for 1 or 2 days. Okay guys. So thank you for watching the video.